We're going to start today talking about our number system. So here's a flow chart. We have different labels that could be applied to different numbers. So within our flow chart here, the box at the top would be a word that applies to every single number. Down to here at the bottom, a couple of specific words that have a small set of numbers that they apply to. So going through history, numbers really started with what is called the natural numbers. These are your counting numbers, 1, 2, 3, and so on. So our numbers started when people needed to keep track and understand how many of something that they have. Now next to natural numbers we have 0, which historically came much later than the natural numbers, and even later than some of these other labels we're going to come up with here. People did not want to give a number to nothingness, because in their mind it was nothing. It doesn't deserve to, or philosophically couldn't have a number assigned to it. But we're glad we have it now. When you put the natural numbers and 0 together, this is what we call our whole numbers. 0, 1, 2, and 3. And guess what the opposite of that is? Negative whole numbers. So it doesn't include 0, but we have -1, -2, -3, and so on. So now you take your whole numbers and your negative whole numbers, put it all together, and that is what creates our integers, which is a word that you've used probably a ton in your math career. So all of our positive and negative whole numbers together. Now the opposite of integers are non-integer fractions. Now if you only look at the second part of that label, fractions, you could get a good understanding of what falls in here. That would be 2/3, 4/5, 7/3, and so on. But what about that first word? Why non-integer fractions? Does that mean that we have integer fractions? And we do. Think about a number like 4/2. Is it a fraction? Sure. But we know that this equals 2, which makes it an integer. So another example, 12/4. It's a fraction, but 12/4 is 3, makes it an integer. Let's add a couple other examples here. For integers, 3, 0, -5. Okay, so let's take all of our integers and all of our non-integer fractions and put these all together. That makes the rational numbers. Now rational numbers, the definition is it's any number that can be written as a fraction. So here you have all your non-integer fractions, and all of your integers could be fractions too, simply by putting a 1 underneath them. So the opposite of a rational number are irrational numbers. And your definition here is just the opposite of this. Any number that can't be written as a fraction. Some famous ones: square root of 2, pi, e. Any number that has a non-repeating decimal falls here. Let me rephrase that. non-ending, non-repeating decimal is an irrational number. If you take all of your rationals and all of your irrationals together, these make up the real numbers. And a good way to think about what a real number is it's any number that could be found on a number line. So if I was to make a number line, square root of 2, pi, and e, sure they look weird, but I know that pi is 3.14, so that would be about here. E, 2.78, would be here. Even square root of 2, it's about 1.4, is here, as well as all of our integers and fractions and everything else. Real numbers can be found on a real number line. Opposite of real? Imaginary numbers. So imaginary numbers, well, numbers that can't be found on a number line for one, but also remember, square root of -1 is I. I think it was about the 1700s when mathematicians said, what, we're not allowed to take the square root of a negative? We want to. And so they decided to call it I, which then allowed them to do math with it. And don't worry, we'll get a chance this year to look at these imaginary numbers a lot. So a few other examples of imaginary numbers: 5i, -6i. Alright, and finally, we take our real numbers, we take our imaginary numbers, put those together, and everything on this page goes into complex numbers. So because this is at the top of the flowchart, every single label we have is also considered a complex number. There's only one type of number that falls here and nowhere else. And that is a number that combines a real number with an imaginary number, such as 3 minus 2i. We say that this has a real part and an imaginary part, so it's a complex number, but can't go into either of these two categories. So keep this chart handy. We're going to be using it a lot throughout the year. The end.